Let's begin. Today is July 5th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So in today's puzzle, we're using the following 5 criteria cards. Criteria card 10, 13, 17, 19, and 20. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And in the bottom row, we've got criteria card D, and we've got criteria card E. Criteria card A looks at our 3-digit solution, and the Turing Machine will let us know how many of those 3 digits are 4. Are there no 4s? Is there a single 4? Perhaps there's 2, maybe even all 3 are 4. Criteria card B looks at our middle and last digit, square and circle, and we'll be comparing them. So should the square value be less than circle? Should they be equal? Or should the square value be greater than circle? Criteria card C again looks at our 3-digit solution and will let us know how many of those are even digits. Are there no even digits? Is there a single even digit? Perhaps there's 2, maybe even all 3 are even. Criteria card D will take a look at the first 2 digits, triangle and square, add them together, and the Turing Machine will let us know whether the sum should be less than 6, perhaps they may be equal to 6, or perhaps even the sum could be greater than 6. And finally, criteria card E will let us know a little bit about the structure of our solution, in that it'll let us know whether there are no repetitions, meaning that all the digits are unique, as in the example 1, 2, 5, or perhaps it may be a double number where there is a single digit repeated, as in the example 1, 1, 2, or it could be a triple number where it's a single digit repeated 3 times, as in the example 2, 2, 2. Remember, the objective of the puzzle is to find this unique 3-digit solution that abides by all of the 5 criteria cards we just described. And we're going to begin with our initial proposal of 3, 1, 4. So the first thing I want to find out is something about the structure of the solution. So I'm going to test criteria card E. Okay, so it does not approve of my proposal. Notice that 3, 1, 4, all digits are unique. That means that it has no repetitions, but the Turing Machine is letting us know no repetitions is not valid. So either it's a double number or a triple number. So let me go ahead and put that down in the notes. So I'll say the solution is a double or triple number. Okay, so at this point, it could be that we just have a single repeating digit, or perhaps it's the same digit repeated 3 times. We do have this criteria card, both actually criteria card A and criteria card C, that will let us know how many 4s there are, or perhaps even how many even digits there are. And then obviously we do have the sum of the first 2 digits, or we can find out a little bit about the ordering of square and circle. So at this point, let me see. I think I'm going to test the ordering. So let me go ahead and test criteria card B. Okay, so the Turing Machine does approve of the proposal 314. So if you take a look, I chose an odd 1 for square and an even 4 for circle. So since the Turing Machine approves, it is true that square should be less than circle. So let me go ahead and put that down in my notes in section B, that square should be less than circle. And so what that means is that square cannot be a 5, because if it were a 5 and it's supposed to be the smaller of the two, then what would circle be? There's nothing for it. And sort of similarly, circle cannot be a 1, since if it's supposed to be the biggest of the two, what would square be? And that's all we can actually cancel for that. Let's see, what else can we test? We could test the sum of the first two digits. I'm just really wondering, with criteria card A and criteria card C having the number of 4s and the number of evens, that potentially we could expect that the sum be 6. But it's interesting that if you know the number of 4s, that means that at a minimum, that number of 4s is the number of evens, but not the other way around, which is very interesting. Because obviously you could have 2s instead of 4s. So I do have a single 4, and I do have the number of evens. But you know what? I think because they kind of work hand in hand, I think I may wait until the second round to test those two cards. So let me go ahead and test, I guess, criteria card D to see if we can figure out anything about our first two digits, triangle and square. So again, let me go ahead and test criteria card D. Okay, so it does not approve of the proposal. Looking at triangle and square, 3 and 1, that sum is less than 6. So that means that the sum of our solution needs to be either equal to 6 or greater than 6. So let me go ahead and write that down in my notes for section D. So this will be interesting going forward, what the solution might be for the overall puzzle. I'm really intrigued. I don't quite remember if I've ever seen criteria card A and C in the same puzzle. So again, the sum of the first two digits are either equal or greater than 6. Well, that does it for this first round. Unfortunately, yeah, let's see, can we cross out anything? I don't think so, because 1 plus 5 could be 6. So how about, this is interesting. Since we crossed out the 5 for square, I don't think triangle could be 1. Because at a minimum, it needs to be equal to 6, and 1 plus, 1 through 4, that's all 5. So that's interesting. So we are able to cross out the 1 for triangle, since we had already crossed out the 5 for square. Very interesting. And yeah, I think we can keep everything else, because this square 1 could be added to triangle 5 for a 6, but obviously nothing else, but it's still valid. And this 2 can be added to 4. Very interesting. And that would still give us a 6. So yeah, so they're still in play. Okay, so I think that does it for everything we could cross out for round 1. As I mentioned earlier, we are in the phase where we'll be discussing and and seeing how we could create a good second round proposal. So we didn't test, again, the number of fours and the number of evens. If you notice, those are all still in play. So it could be that we have a sum of 6. That would be interesting. And again, the interaction between criteria card A and C is also very interesting. Okay. Oh, I think we can eliminate the triple number because we already know they're not equal. Okay, fair enough. So we've already eliminated the possibility of them all being a triple number. So since squared cannot equal circle, that means it can't be a triple number. So it is indeed a double number. All we know is for sure that square has to be less than circle. Square has to be less than circle. So as far as the first two being equal, it could be 334 or 335, and that would tell us the number of fours. It could be 445. You know what? I think I'm going to start. Let me start typing some of these up. So let's pretend the first two are even. Sorry, first two are equal. So it could be 334 or 335. Okay. And if it's 44, it would be 445. And I think that those are the only cases where the first two are equal, because they all have to, or the first two have to add up to be greater or equal to 6. Okay. And then the only other possibility is if the first and last are equal, because we know the square and circle have to be non-equal. So it could be 4. Yeah, it would have to be 242. And that's it for triangle 2. It could be 343. Okay. And I think that's it. You cannot have fours or, well, I guess you could have 515. Is that the last one? That's interesting. So first 2, 3, 3. Okay. 3, 5. And then 4, 4, 5. And then the first and the last are equal. So 2, 4, 2. Oh, what am I saying? Hold on. No. It can't be 2, 4, 2. Or 3, 4, 3. But it could be 515. I'm not sure what I was thinking there. So let me go back and see, what did I miss? So it's got to be, okay, so both triangle and square have to, triangle and circle have to be greater than square. So yeah, that's why 515 works. And so I guess, yeah, so I guess 525, yeah, so there's going to be a lot of 5s there. Let's see, 525, I'm just wondering if it's worth typing them all up. 535, and then 545. Okay, and what about 4? It could be 434. And 424. And I think that's it, because it can't be 3-2 or 3-1. Okay, so we got I think I'm just going to pick something that adds up to 6, and I'm going to pick the all even, 424. Okay, so let's go ahead again and test criteria card D. I want to see, well, let's see, if I do 6, it's either because there's 4s and evens in there. Let me go ahead, I'm still going to test it. D. Okay, so the sum is not 6. Okay, so at least I can cross this out, and I'll cross out all of the sums that are 6. Okay, so it can't be these first two, and it cannot be this last one. Okay, so obviously those are all where the sum is greater, and they are. Okay, so I think that means that triangle cannot be 2 or 3. I don't know if that really matters. Obviously, we can see no 2 or 3 for triangle, but there are some 4s. So let's see, we've got two that have 4, a double 4, and all these are double 5s. Okay, very interesting. And we do have, okay, maybe we can eliminate 515 and 535. Oh, this is also a 6. Okay, never mind. That's also a 6. I did not see that one. Okay. So here we have a double 4, and here we have a double 4. So I think we can eliminate those two because they're both doubles and 2 evens. Yeah, so we've got double 4s. Yeah, the square is less than the circle. They're both even, they're 2 evens, and both sums are greater than 6, and they're both double. Yeah, so I think I can cross these out because they would be ambiguous. So both of these are ambiguous. Okay, what about the remaining? So this has no evens, no 4s, 1 even, no 4, 1 even, 1 4. And so we're left with 5s. Okay. Well, again, we do have a single even, and then a single 4. If we test, I guess if we test the number of evens, it may keep these two alive, or it could reveal that to be the solution. I guess actually maybe even criteria card A would be the best one now. Either there's a single 4, well, I guess, oh, that's not going to be good for me because I picked 2 4s, and that's not viable anymore. That's just going to give me an X and not give me any information. At least if I test criteria card C, I could get lucky with, well, no. Oh my gosh, I think that was probably the worst proposal, because that's also not going to give me any valuable information. Wow, how did that happen? That is not going to give me any valuable information. Wow, I think I have to abandon this round, and I can only salvage it I won't beat the Turing Machine because I think I'll be going to 3 rounds, but at least I could tie at best the number of queries. Okay, so what would be the best alternative? What could possibly happen? And if there are no evens, okay, there we go. If there are no evens, then you know there are no 4s, and that wouldn't help out if there are no evens. So I think we can eliminate 535, and then now we just have to test whether there's a 4 or not. Okay, so let's go ahead and do that. I'm going to choose 545 and just test criteria card A. So I'm going to do a new round, 545, and test criteria card A. Okay, so there is not a single 4, and we've already eliminated all the double 4s. So is it safe to assume 525? Oh gosh, was that right? If there are no evens, then we know there are no 4s. That doesn't help. So there's got to be at least one even. And so it's got to be 525. Okay, I'm going to go with my instinct and say it's 525. This has been quite a challenging puzzle. So 5, 2, 5. All right, let's see what the Turing Machine says. All right, fantastic. So we got the 525. So the Turing, comparing the Turing Machine, that is going to be interesting. Wow, look at this. This is pretty interesting. 3 rounds and 5 queries. Okay, so I tested B, D, E, and then D, A in 2 different rounds. B, D, E, D, A. B, I already forgot what was correct. Okay, B was correct. B, D, E, D, oops, B, D, E, round 2 only D, and then round 3A. This is going to be interesting. Wow, look at that. I was saved by the fact that the Turing Machine also took 3 rounds. I think this is a first. 3 rounds, 5 questions. That is, yeah, that's very interesting. I don't think I've ever seen that before. Well, so not sure what to say. I hope this was a good video. It's probably going to be on the longer side. But if you do have any comments to see what sort of efficiencies you think I should have had the opportunity with, if you've ever seen something like this before on the scoring of the Turing Machine, please do add that to the comments. Or have you ever had a proposal that, for all intents and purposes, was really not helpful at all? In the second round. Well, it was helpful in at least eliminating the sum of 6, but other than that, wow, I am still very blown away. Well, in any case, so do add any comments if you'd like, and if you like the video, please give it a thumbs up, and please subscribe to be notified if you do not want to miss any future videos. Well, until next time, have a great one.